Let us solve these problems together. For each of the following substances, circle the one intermolecular force which would predominate in the solid or liquid phase. These 6 substances are given to us. Let us begin with the first one, Al2O3. Does it have London dispersion interaction? Yes, it does. Actually, every compound would have London dispersion interaction in it. Every molecule. So, all of them will have London dispersion forces. Does it have dipole-dipole? Nope, it does not. It is an ionic compound, and ionic bonding is the strongest bonding we have in chemistry. Ionic bonding is the strongest in chemistry. So, in Al2O3, ionic bonding will predominate. Let us take a look at the second one, F2. Before you answer that question, the very first thing I would suggest you do is to draw the Lewis structure for F2. And if you draw the Lewis structure, you should get something that looks like this. Now, does it have London dispersion? Oh yes, it does. Like I said earlier, every compound would have London dispersion interaction. Does it have dipole-dipole? Nope, it does not. Why does it not? The reason is because dipole-dipole is only found in polar compounds, and F2 is non-polar. Both fluorine are equally electronegative, so there is no polarity. This is a non-polar molecule. As a result, there is no dipole-dipole. Does it have hydrogen bonding? No. For hydrogen bonding to be present, you need to have hydrogen bonded to fluorine or hydrogen bonded to oxygen or hydrogen bonded to nitrogen. And these 3 cases, we do not have any of them in F2. So, it does not have hydrogen bonding. Do we have ionic bonding in F2? No. There is no metal. For you to have ionic bonding, there must be a metal. So, what is the only intermolecular force present in F2? That would be London dispersion. And since it is the only intermolecular force present, it would also be the predominant force. Let us now move on to the next one, which is H2O. Again, before you answer questions on any intermolecular forces, draw the Lewis structure of the compound if it is a covalent compound. What is the Lewis structure for H2O? The Lewis structure is like that. From the structure, we can immediately see that this is a polar molecule, which would suggest that it would possess dipole-dipole interaction. But wait, we also have hydrogen bonded to oxygen. That is hydrogen bonding. Actually, remember, hydrogen bonding is a special type of dipole-dipole. It is a dipole-dipole, but a stronger dipole-dipole. So, in H2O, the strongest intermolecular forces we will have will be hydrogen bonding because H2O is not ionic. Let us move on to the next one, Br2. The Lewis structure for Br2 is kind of similar to F2, which means this compound is nonpolar. It is nonpolar and there is no metal present in it, which means that it cannot be ionic. And since it is nonpolar, it cannot be dipole-dipole, neither can it be hydrogen bonding. If it is nonpolar, you can simply rule out dipole-dipole and hydrogen bonding. So the only intermolecular forces that we will have will be London dispersion forces. Let us move on to the next one, ICl. If you draw the Lewis structure, it looks like this. The next question, is this compound polar or not? This compound is a polar substance. How do I know? Because chlorine is more electronegative than iodine, which means that the electron density in this compound will be closer to chlorine than to iodine. So if it is polar, we definitely know that it will have dipole-dipole. Does it have hydrogen bonding? Nope, it does not. Is it ionic? No, it is not ionic. So the predominant intermolecular forces in ICl will be the dipole-dipole. And lastly, let us take a look at NaCl. This is an ionic compound, so we do not need to draw any structure for it. And if it is ionic, we already know that ionic bonding is the strongest intermolecular forces you can have. So the predominant interaction here will be ionic. Let us now move on to the B part of the question. The B part wants us to rank the substances in order of their boiling points. Remember that boiling points is directly proportional to intermolecular attraction, which means the stronger the intermolecular forces, the higher the boiling point. Based on that, we can immediately say that the two ionic compounds will be at the highest level of the boiling point. The question is, which of the two ionic compounds will have the higher boiling point? And that will be Al2O3. And this is the question. How do I know? Well, the intermolecular forces is not the only forces we would have to take a look at. We will also need to take a look at intramolecular forces. Now, for NaCl, we have a compound that has +1 on sodium and -1 on chlorine. But for Al2O3, we have a compound that has +3 charge on aluminum and -2 charge on oxygen. +3 -2 interaction will be a lot stronger than +1 -1 interaction. That is, the intramolecular interaction in Al2O3 will be stronger, and that means it will have the higher boiling point. So sodium chloride will be the next. After the two ionic compounds, then the next compound in order of intermolecular forces strength will be the hydrogen bonding. Hydrogen bonding is the next stronger intermolecular forces after ionic bonding. So that means water will be the next in the rank of boiling points, H2O. After that comes dipole-dipole. Hydrogen bonding is stronger than dipole-dipole, and we only have one compound with dipole-dipole, that is ICl. And after that would be the dispersion forces. Now again, we have two compounds here. We have F2 and Br2. Which one will have the higher boiling point and which one would have the lower boiling point? Remember that dispersion forces depend on molecular weight. And bromine has a higher molecular weight than fluorine, which means that the dispersion interaction in bromine will be stronger than in fluorine. As a result, bromine will be the next, and the last will be fluorine.